Today we're going to transform this overhang into a Disney Style Transom window. What's a transom window, you ask? This is a transom window, and there's many of them at Disney World. Ours will be an interior transom window. Stick with me today, I'll show you exactly how you can build this for yourself. Thank you so much for joining me today. My name is Larry. Before we get started, remember there's no greater tool in your workspace than your safety gear. Always wear ear and eye protection when working in your workspace, and sometimes more when you have to. Now, let's go build some magic. Thanks again for joining me. Now, let's get right to it. The location for this transom will be underneath this balcony. It'll stretch from one wall to the other and be secured to the ceiling. So to visualize this, I've made this graphic where this is the glass and this purple represents the frame. But first we need a design. Now, I could use 3D software to create my design. However, I find hand drawings and simple math is the easiest to use. Plus, it only takes paper and pencil and a calculator for you to recreate this yourself. So, when I'm finished, I've got this drawing and all kinds of usable information on here, including the names and location of each component, like this top plate, this upper rail, obviously the glass in between, this lower rail, the bottom plate, and this running trim. Also included are these important pieces of information, the dimensions. From that drawing, I was able to produce this three-dimensional drawing that has the same information. The top assembly components and the bottom assembly components. Plus, I included this LED pocket on the top and bottom. This will be part of a future build. So, from the design, I went ahead and made myself a prototype. I'll use this prototype to make sure that all the dimensions work and make sure it spatially works within my shop. Now, I know that my prototype only has 2.5 windows, but it's used to conceptualize what the larger transom will eventually look like. Once I take a look at it from different perspectives from around the shop, I'll take a couple measurements, and we're good to go. The first thing I'm going to tackle are these LED pockets. I won't use them now, but they help me future-proof future projects, if that makes any sense. I start by using my router table, easily the messiest tool in my shop. I've got to make more than one pass on this pocket because the router bit just doesn't go that deep on the first pass. But pretty soon I've got the right depth, and I'll repeat this on the second plate. Next up is this channel for the running trim. I go back to the routing table and once again use this to cut this channel. I'll have to make multiple passes again, but this time not for the depth, but for the width. Once that's complete, I use the final product and compare it to my drawing. Here's the bottom plate on the drawing and the bottom plate in real life. The running trim on the drawing and this mock-up. The LED pocket and the LED pocket. You'll get the idea. Next up, let's cut the running trim to size. From this drawing, I know that the running trim has to be 1 3/4 inch wide. I adjust the fence on my table saw to 1.75 inches wide. Adjust my blade to the height it's supposed to be. And it's just a matter of feeding boards at a steady pace. Because the width of the transom has to be 132 inches, I've got to cut multiple boards. Next up are the muntins. Yes, I said muntin. These are the boards that fit between the panes of glass. They fit between the upper rail and the lower rail, and they're 8 and 5/8 inch long. So, because I have 15 of these, I cut multiple boards at once. First I measure, align my mark underneath the blade of the chop saw, and then I just cut. And cut. And cut. Pretty soon I've got all the muntins I'll ever need. Next up is the upper and lower rail. I'll have to cut them to the proper thickness, which is 1/2 inch. So I set up my table saw again, only this time I set it for a width of 1/2 inch. I adjust my blade height once again, and then it's just a matter of pushing boards through at a steady pace. Now that I've got these cut to the proper thickness, it's on to the final boards. Next up is the running bead. I originally show it in my drawing as quarter rounds. These hold the glass in on both sides. I'll need 112 of these. That means there's going to be 112 corners to address. If I stick with quarter rounds, that's 112 miter joints I've got to get perfect. Or I can go with a square butt joint, which is much more forgiving. Instead of cutting them all individually, I bundle them together, flush up the ends, and then tape them together so they don't move around when I cut. Once I tape a couple bundles together, I simply true up the ends by cutting just a width of the blade off, and then I lay out my measurement. This way I can cut 20 boards at a time, set the mark underneath the saw, and then, you guessed it, cut, cut, cut. By choosing the square butt joint, I was able to cut all of the boards all at once, which took far less time than 112 perfect miter joints. And with that, we're done shaping. First, we're going to build this bottom assembly. I've clamped the bottom plate to the table so I can install the running trim. Because the width of the transom is 132 inches wide, it takes multiple boards to span that distance. Therefore, this bottom plate is in 2 pieces. This running trim will be the first piece that ties those 2 pieces together. I use that scrap piece to fit the running trim into that channel we made earlier, and then I make sure the end is flush. Next, I secure the running trim onto this bottom plate using this finish nailer. I make sure to secure all the pieces together, knowing that there's multiple boards across this entire length. Also, the bottom assembly is the only one that has running trim. Now, because there was a channel, it was easy to place the running trim inside of it and then simply secure it. Next up is the lower and upper rail. Because there's no channel here, I need to make sure that there's proper measurements throughout the length of this assembly to ensure that the rail gets assembled in its proper place. Once all the measurements and marks are made, I can simply take that rail, align it with all my marks, and then clamp it into place. Next, using my finish nailer again, I make sure I secure all these boards together, all the way across its entire length. I secure the upper rail on the upper assembly in the same way. Next, I clamp the bottom and top assembly together, making sure that the tops are flush. This way, I'm able to accurately measure the location for each muntin. That way, when I assemble the top and the bottom assembly together with the muntin, I'm assured that they're going to be square when I clamp the entire assembly together, and then square when I finally screw all the pieces together. Next, I place this temporary blocking that's the same dimension as the muntin. This will allow me to take the top assembly and place it on the bottom assembly, and then lightly clamp them together. But first I've got to make sure that the top assembly is square with the bottom assembly. So I use my square, make a little adjustment, and then I'm able to place the muntins into the assembly and then clamp like crazy. Now, this may seem like overkill for the number of clamps I have, but if you've ever assembled two assemblies together like this, using multiple pieces in between, you'll know how difficult it can be. So multiple clamps is definitely the way to go. Flash forward to the future, I want to draw your attention to this channel. This was a mistake, but instead of scrapping this board, I chose to keep it. This channel will face the ceiling, so this screw-up won't be seen in the final product. Now you can see how the muntin is the only thing assembling the top assembly and the bottom assembly. Flash back to the past, and we actually have to secure these two assemblies together. So I make marks so I can drill and countersink for each muntin on the upper assembly. So why do I drill and countersink? Well, this ensures that the wood doesn't split when I'm driving the screw into place. Next up is screwing the two together. Now, you'll notice I don't screw the first screw in all the way. Why is that? Well, because the muntin is only clamped in place, if I screw the first screw in all the way, the muntin has a tendency to pivot in place around that screw, taking it out of alignment. So to combat that, I simply drive the first screw in part way, securing its place, and then I drive the second screw in all the way, and then go back and finish the first screw. After flipping the assembly, I'm able to secure the muntins on the other side using one screw for each. Next, I'm moving on to placing the running beads. I measure and mark each window pane area, eventually measuring all four sides of each window pane area. This ensures that I get each running bead in its proper place once assembled. I also go back and mark each window pane area with a number, because each of these glass openings are slightly different, and I want to trim the running beads to best fit each area. Now, using my measurements and marks, I'm able to start placing the running beads in each area. You'll notice I'm only placing one running bead in each window opening area at a time. This is purely for convenience. I'll flip the assembly in a minute so I can assemble the opposite running bead. Ensuring that each of these running beads is in their proper place is important. It will ensure that the glass sits square and flat once it's assembled inside each of the glass areas. Now I need to secure the side beads by first measuring and then trimming them so they fit perfect in each of the openings. So I take my measurement over to the chop saw, align it with a blade, and simply cut off what I don't need. This will make sure that each set of running beads that go along the side of each area will fit optimally. Once I measure and cut each side bead for each area, then it's just a matter of going back, flushing them up to the top and the bottom bead, and installing all the rest. And yes, this is a very tedious process, but it doesn't require a great deal of skill. It merely requires patience. So, just take your time. So, before I go to the big box store to get the glass, I've got to make sure it's the right size. So I made this mock-up of the glass at the exact size I need, and now I can use this to test in each one of the areas just to make sure that I get the right glass size. So, taking this mock-up and tipping it into place in each one of these openings gives me the confidence to know that that is the exact glass size I need. With the entire assembly created, now I want to test to make sure that the width works and that the height, well, that I got it right. So I simply take the assembly and pull it up into place. I already have these clamps in place, so I simply rest the assembly on those clamps and then go back and secure it in place. Now that I know it fits and it looks great, it's on to paint. I'm using this white primer to prime all the boards, and I'm also using this chip brush to make the application. Chip brushes are inexpensive and can be found in a big box store or any hobby shop. The only downside is chip brushes won't give your paint a nice smooth surface once it's applied. So I flip the frame over here so I can paint the backside, making sure I get to all those tight corners. Primer has never been a whole lot of fun to apply, but it helps the finished coat last longer, and I think it makes it look better. Next, I moved on to the finish coat, and I chose this Luxury Limited. I chose it because it has kind of an off-white look, and that makes it look kind of aged. You'll see I applied gray primer to these running beads, and that was a mistake, but that's easily corrected with the finish coat. You'll notice that I numbered each bundle of 4 of these running beads. Those correspond to the number I wrote on the frame earlier. Now that I have the first coat down, I'll finish up with the second coat, and then I'll be complete with all my finish coat on the running beads. Next up is the frame. I'm using this tapered nylon brush so I can get into all those tight corners and give the paint a really nice finish. I ultimately chose not to give this frame a second coat because, after all, this is for my shop. I did, however, go back and use this artist brush to do some touch-up work on areas I just couldn't get to. So now that I know that my mock-up will work, I went ahead and bought this glass in the exact size that I needed. Now, it's not glass. Instead, I went with plexiglass. Now, I noticed that this plexiglass is not clear, and that's because it has 2 protective coatings on either side. However, I do like the way it's frosted. Now, I can't leave the protective coating on, so I bought this frosting product that will give me the haze that I need. So I went ahead and laid out all 14 panes, and then sprayed as evenly as I could across all of them. Unfortunately, I was unhappy with just one coat, so I went ahead and applied a second coat. And with that marks the end of painting, except for some minor touch-up work. Next, I'm going going to install the glass, but first I'm going to cut these thin felt strips. I'll place these strips underneath each pane of glass as I install them. Even though this transom will be an interior element, this wood will still expand and contract. The felt will keep the glass from rattling if the running beads happen to expand away from the pane. I install the bottom bead first, then the top, and then I move on to the sides to complete each pane. This gives you a better idea of how I install the felt. First I lay it in that corner, install the pane of glass, lift it, and then I just sandwich that in between using the bead. Now it's just a matter of repeating that process across 12 of the 14 panes. 2 are left open so I can hang the nearly finished transom on the clamps. I move the nearly complete transom into place so I can lift him onto those waiting clamps. Next, I use some serious man muscles to lift my nearly finished transom into place. I tighten the clamps and then I take one last look to make sure everything looks good before I install it. I use this miniature crowbar to make sure the transom fits tight against the wall. I install the shim and then I start screwing holes for the screws. Now I can secure the transom to the wall using screws, one into the ceiling for good measure, and then I simply tear the tape off this shim. I repeat the process for the other wall, but now I have to install the 2 remaining glass panes. This process goes the same as I did on the workbench, just a little more tricky when I'm on the step stool. I also go ahead and install screws down the entire length of the transom. This makes sure it's secured tightly to the building. I install the final pane, and with that, install is complete. Here's a close-up look of the transom installed, noticing the haze of the glass. I take a look at the final product, and I'm pretty happy. That's it for today's video. Thank you so much for joining me. Again, my name is Larry. Make sure you hit like and subscribe, and turn on your bell for notifications so you never miss any of our magical content. And remember, friendships are born the moment you choose to smile back. Now go build your own magic.